If you watched our last video, we know that we're going to start this problem by drawing a right triangle to help figure out our other trig ratios. First thing though is I need to figure out what quadrant my right triangle is going to be drawn in, and to do that I need to use the two pieces of information they gave me. They've given me the sine of theta and they tell me it's 1/3, so what I know is that the sine is positive. They're also telling me that the secant is less than 0. In other words, they're telling me that the secant is negative. Well, what I like to do, I don't like to think in terms of the reciprocals, so I know that secant is just the reciprocal of cosine. So really what I need to, the information I'm going to use is that the sine is positive, but the cosine is going to be negative. So thinking back to our unit circle and these four letters, A, S, T, C, the quadrant where sine is positive but cosine would be negative would have to be here in quadrant 2 where sine is positive but everything else is negative. So my right triangle is going to be drawn in quadrant 2. So let's go ahead and do that. And it does matter what quadrant that triangle is drawn in. So from the x-axis, from the origin and then connecting to the x-axis, this is what my right triangle is going to look like, and theta is always with the x-axis. So let's label a couple sides. Sine, recall, is the opposite over the hypotenuse. So what they've told me is the opposite side is 1, the hypotenuse is going to be 3. And just a note for yourself that hypotenuse is always going to be positive no matter what. I can see that 1 is positive because it goes up. If you think of in terms of coordinates, it's a positive 1. What's left though is this adjacent side, and I can see it should come up to be a negative because it's going to the left. Now I don't have enough information that they gave me to find that side, but I can do the Pythagorean Theorem to find that third side. So let's go ahead and do that. So I'm going to say 1 squared plus the missing side squared. I'll use x. It is the x-axis, but be careful about that. It needs to be equal to 3 squared. So when I solve this, I would subtract 1 from both sides. So I get x squared is equal to 3 squared minus 1, which is 8. And then I would take the square root. Well, that can be simplified. So let's go ahead and simplify the square root of 8. If you don't recall how to do that, I can show you in class. But that side works out to be the square root of 2 over 2. So my adjacent side, if I go ahead and label that back on my triangle, is going to be square root of 2 over 2. But remember, that went in the negative direction, so I need to throw a negative on that, and that does matter. So now all three sides of my triangle are identified. I can go ahead and answer their question. They wanted me to find the cotangent of theta, and they could ask me to find anything, but now that I have all three sides, who cares if they ask me? It's not going to be hard to find those. So to find the cotangent of theta, I might want to start first with tangent. Remember, tangent is the TOA part of SOHCAHTOA. So tangent would be opposite over adjacent. Because I'm doing the reciprocal, I need to flip those. So I need the adjacent side, which I just found out was negative square root of 2 over 2, over the opposite side, which is 1. And I would need to simplify that if necessary. This time it's not necessary to simplify it. It's already simplified. So there is my cotangent of theta, negative 2 square root of 2. All right, let's try one more example down here. Again, a slightly different setup because this time, again, they only give me one trig ratio. The secant is negative 5 over 3, and they tell me what quadrant the triangle is in. So I guess this one might be even easier than that one we just did because we don't have to figure out what quadrant our triangle's in. They've told us it's in quadrant 2. So let's go ahead and sketch that triangle in quadrant 2. So from the origin and then connect to the x-axis. Your angle's always there. Between the x-axis. And I want to figure out what my sides are going to be. Again, they gave me secant. I don't really like working with the reciprocals, so what I might do is I might rewrite that as cosine of theta, and recall that all that will do is flip it. It'll get the reciprocal. So the cosine of theta would be the negative 3 over the 5, so the adjacent over the hypotenuse. Or if you left it original, you could think of it as hypotenuse over adjacent. I just don't like thinking of those. I like the original sine, cosine, tangent. So anyway, I gotta label those sides. Well, as I mentioned in the last problem, our hypotenuse is always going to be positive. So positive 5 is going to be my hypotenuse. My adjacent side, this one down here, is going to be negative 3. I can either remember that, well, the hypotenuse is always positive, so that's where my negative sign would have to go. Since that negative was in the middle of the ratio, I wasn't really sure which one to put it on. Or just remember in terms of graphing, that's a negative 3 in that direction, so that's negative. All right, so I need to find that remaining side like we did last time. I'll do Pythagorean Theorem to do that. We can use x, but since it's a y direction, I might use y this time just to be careful. So I've got y squared plus negative 3 squared. Make sure that's in parentheses when you square it or it will be wrong. And maybe you already know this without doing Pythagorean Theorem because this is a triple. I get y squared plus 9 is equal to 25. And when I subtract, I get y squared is 16. Yay, no square roots to simplify this time. I just get 4 for that remaining side. And then, as I mentioned, it's a triple, so maybe you knew it was going to be 4 because you know it's a 3, 4, 5 triangle. Since that side is moving up, I know it's a positive 4 for that side. So now that the triangle is done, answering the question shouldn't be too bad. I want to find out what the sine of theta is this time. So sine, recall, is the opposite over the hypotenuse. Well, we just found the opposite side to be 4. We know the hypotenuse is 5, and I would simplify if I needed to. I don't need to this time, so that's my answer.